All right, here's the first homework assignment of the term. It's 1.7, dealing with inverse functions. What I want to do in this video is relatively quickly flip through each of the problems. There's 13 in this assignment, and just talk about each one. Try to preemptively find any little things that might cause frustration. Try to give you little hints and tricks wherever I can. Essentially try to make your life a little bit easier, because I know trying to do your homework on a computer system like this can be a little bit frustrating. So for this first problem, you're given this graph. This is f of x right here shown in blue. And what you're supposed to figure out is which of these graphs below, which of these three, correspond with the inverse of this function. And I think what the people who wrote this problem had in mind is you can come up with the graph of the inverse function from the function by reflecting it over the line y equals x. So you're supposed to kind of visualize what this would look like if you reflected it. And if you can do that, great. Although for some people that's really hard to visualize. So another way you could do it is by finding some points on this graph. Like for example, this graph, it looks like it goes through the point 0, 1 right here where my mouse is. So what that's saying is that when the input into the function is 0, the output is 1. But if you think about the inverse function as switching inputs and outputs, then an input of 0 and an output of 1 on the function would correspond with an input of 1 and an output of 0 on the inverse function. So maybe you can think about what would a graph that has an input of 1 and an output of 0 look like? What point would that go through? And maybe just by finding that point, that can help you narrow down or maybe even solve the problem. What I'm saying is either you can do this by reflecting the graph, or you can do this by finding specific points and kind of using a process of elimination. The second question has more to do with graphs here. We're given the graph of a function, and these first two questions, they're more review from, I guess, Math 111. This is asking you if you put 0 into this function, what would come out? It'd be nice if you understood that we can get that off the graph by finding the x coordinate equal to 0 on the graph, which means as far left and right as I'm going is 0, and asking what is the height at that point. So this point right here, 4, will end up being the answer to this question. Don't believe me? There it is. Because when I put 0 into the machine, 4 comes out. When the x value is 0, the y value is 4. And maybe you can do something similar down here. Now they're telling you the output and asking you for the input. And then they start asking you questions about the inverse function. And you're like, how am I ever going to answer these questions about the inverse function when the graph of the inverse function isn't even pictured? Well, I guess you got options. One option would be you can come up with the graph of the inverse function, because we know how to come up with the graph of the inverse function from the function. That's what we were talking about in question 1 where we're reflecting. But maybe easier than that would be the final example video that I made. I talked about how questions about the inverse function can be translated into a question about the function, kind of switching inputs and outputs. So maybe you can answer these two questions without ever knowing what the inverse function graph looks like, just by using the graph of the function itself. Question 3 and 4 get into function composition. They give you a function, then they give you another function. They ask you the question, are these two functions inverses of each other? Well, if they're inverses of each other, then when we do one and then the other, informally speaking, when we compose them together, nothing should happen. The composite of f and g should just be equal to what's called the identity function, x. So compose the two of them together and simplify, and what you'll see is if you get x for the answer composing them this way and composing them this way, then one is the inverse function of the other. So you compose them twice, and then based on those two answers, you can answer part C here. Same thing for question 4. This is really just getting some algebraic practice for you. It would be nice if you could compose these. That's a good skill to have. And it would be even nicer if you could take that composite, which is going to be kind of a mess, and simplify it all the way down to either an x or not an x. And then that will tell you what to put in these boxes, and you can answer this question. Question 5 gets more into the meat of this section, where you're given a function and asked to find the inverse of that function. In fact, that happens several times. In the videos, I think I demonstrated this for a linear function like you see here. And then for functions more like you see in 6 and 7 in the last video. The idea for all of these, and I think even the next few problems, will be that 4th step process. So first change f of x into a y, then switch your x's and your y's, and then solve for y, and then change that y into f inverse of x. And what you get is what you'll write in this box, and then again in this box, and then again in this box. When you get your answers, be really careful with parentheses and everything. It's worth pointing out you don't have to type all your answers in, using your keyboard. This has this functionality where, like, if you want something squared, you can put it up in the exponent here. If you want the square root or the cubed root, you can use all of this different stuff. Question 8 is more of the same, where you're trying to find the inverse function, except now what you have is more of a rational function. So this was the second of the example videos that I made that kind of show how to deal with this problem. 9 more of the same, you could tell, wow, there's a lot of these questions. Why are you making me do so many of these? This is really the key skill that I want for this section. I want you to, if I give you a function, come up with the inverse function. The rest of this stuff is good. Like, it's nice if you understand the graphs and have this conceptual idea of inputs and outputs. Composing functions together, that's great, but really the most important thing is if I give you the function, can you find the inverse? And the problem with that is it's always this 4-step process, but the third step where you have to solve for y is different depending on what function you're given. And the algebraic skills to solve for y will be really important. So I want to hit those kind of hard on this homework assignment, which is why you have so many of these. Hope it's not too much. Question 10, more of the same. You have what looks like a rational function. The fact that this is just a 1 up top will make life easier, but solve this just like I did in the second example video. Question 11 looks a lot like the rational function video that I gave you, although it's worth pointing out that you don't need to find f inverse of x. It's not asking you for f inverse of x like it did in this previous problem. It's asking you for f inverse of -5. And as we saw in the final video, you can find f inverse of -5 2 different ways. One way is finding f inverse of x first, and then changing all the x's into -5s. But there's also a way to figure this out without ever figuring out f inverse of x. 12 is probably the hardest problem on this homework assignment. It looks a lot like 11, except instead of finding f inverse of a number like -5, you're finding f inverse of x. I anticipated this to be the hardest problem, so I made a video that's meant to be very similar to this problem. So this is the second of the example videos that I made, and hopefully that'll work for 12. And then 13, you could do it or you could skip it. It's totally up to you. And that's not just for this assignment. That'll happen on every homework assignment this term. The last problem on every one of these homework assignments is purely extra credit. And sometimes it'll just be another problem that's a good thing to do. And sometimes it'll be something related to the topic that you don't really need to be able to do, but I guess it's good practice. And that's what it is in this case. You don't really need to be able to do question 13 for the purposes of our class. But if you do, you can get some extra credit. What you're supposed to do is they give you the function, find the inverse of that function. That should be easy because this is linear, so I think you'll have no trouble finding this. But then sketch the functions. That's the part that made this extra credit. It would be great if you walked into this class with the ability to graph linear functions. If you knew how to look at this and determine the y-intercept and the slope, and then come up with 2 different points, and then the line that connects those points is the graph of this function. And same thing with f inverse of x. When you get your answer, you want to write it into y equals mx plus b form. And then using the b, you can find the y-intercept, and using the m, you can find the slope. And using this little graphing tool, you can be like, I don't know, here's my y-intercept, and then based on the slope, it goes up 1 and it goes over, I don't know, 4. So here's my line. So what you're supposed to do is do that for 2 different functions, f and f inverse, and you'll kind of know if you got things right? If your answers look like this, you're like, wait a minute, there's supposed to be some symmetry going on between a function and its inverse. If I take this and I reflect it over the line y equals x, it doesn't look like it's going to land on this. I must have screwed something up. At any rate, if you have the patience for all this and you want to sketch those 2 functions in here, you can get some extra credit on this homework assignment. But if you don't want to do that, don't feel pressured. You don't have to. That's all I got for this video.